Hi guys, welcome to another episode of my YouTube video. In today's video, we are going to be looking at question under the progressive wave question. So we have a question like here. It say that a plane progressive wave is represented by the equation y, which is represent the direction of the wave, which will equal to 0.3 sine 200 pi t minus 20 pi x upon 18. So this is the equation that we are given. The next step we should find the frequency of the wave, the wavelength of the wave, the speed, and its amplitude. So these are what they ask you to find. So solution. So generally, you know that generally from the progressive wave equation, we have y to be equal to a sine bracket wt, which is this w will represent our angular velocity phi, which is the phi phase angle. This is phase angle, this is angular velocity, this is time. A will represent the amplitude, while the y will represent the direction. You know what sine mean? It is the sign of the angle. So the A is the amplitude. So let's represent it with the equation. So the equation we are in wave, we have W. This W will be equal to 2 pi f normally. The always equal to 2 pi f. So and you know that f, which is, let's start from, let's write like this, that V to be equal to, V can be equal to F lambda, and F can be equal to V upon lambda. So I can replace this with this now. So this can now equal to angular velocity again to be equal to 2 pi V upon lambda. Also, the phase angle, which is phi, can also be kx, and the k, which x represents the distance, and k alone can be equal to 2 pi. K can be equal to 2 pi, bring down the x upon lambda. So now note that k is always equal to 2 pi upon lambda. So from the question now to the question, we have, so we should find the frequency. So for I1, we want to solve for the frequency. We have, so W will be equal to 2 pi f. And from the question, if you go back to the question, all the value that we have here before t, they are W, which is our angular velocity, and all the value that we have before x here is going to be our k, which is the wave number. So now let's write it like this: W will be equal to 200 pi, and the k also will be equal to 20 pi upon 18. That is our given data. That's what we are given. So after that, our W is equal to 200. So we input it here. We are solving for the frequency. From the first statement they asked us to find here, 200, is it 200 pi to be equal to 2 pi f. If I should make the f as with the formula, we're going to have 200 pi upon 2 pi. So this one cancel this. So f will now be equal to 200 divided by 2 will give us 100 terax. So that's for our frequency. So for the second next question, the second we should find the wavelength. So the wavelength, you can get it from k to be equal to 2 pi upon lambda, and our k is equal to 2 pi upon 18 to be equal to 2 pi upon lambda. If you cross multiply, make the lambda as base of the formula, you're going to have, which is the wavelength that we are looking for, you're going to have 18 multiplied by 2 pi upon 20 pi. This one you cancel this, so you're going to have 18 multiplied by 2 divided by 20. So it's going to give us 18 multiplied by 2 divided by 20, is going to give us 1.8 meter. So for the last question, they said we should calculate the velocity, I mean the speed. Second to the last question, the speed is going to be v to be equal to f lambda. We have our frequency already here, which is 100, And we also have our lambda here, which is 1.8. So if you multiply it, so we have 100 divided by 1.8 is going to give us 180 meter per second with the unit. So the last question, which is our figure 4, is we should find the amplitude also. So we should solve for the amplitude. So the amplitude, you're not going to calculate it, we just pick it out from the question. This is A. Go to the question, we see where A is 0.3. So our amplitude A, which is equal to 0. Our amplitude is equal to 0.3.